Next up, we have Peter Friedrich of Industrial Magnetics here to demonstrate some of their very innovative products. As before, please post your questions using the Q&A button at the bottom of your Zoom window, and the guys at Industrial Magnetics will answer your questions at the end of their session. So at this time, I'd like to turn it over to Peter and Industrial Magnetics.
Hi, everybody. My name is Peter Friedrich from Industrial Magnetics. This is Paul Hardy. He's going to assist me today in demonstrating some products. We've got some really exciting news to present today and some really great products. One of them, one that we just introduced, is our lifting Bale Lockout. So anything that has a lifting point, whether it's a magnet, a chain sling, a lift eye, pad eye, hoist ring, anything that has a lift point, we can now lock that out. So you can use a product or can't use a product that's deemed unsafe. It comes in two sizes depending on how big your lift lug is. Lots of adjustments, but the concept is it goes around the lift point, prevents some operator to use the hook and be able to use a product that's either damaged or the label's not legible and the lift point is just not able to be used. Then we have our line of FX magnets. It's a great line of magnets that we're really proud to introduce. When you look at our Power Lift, one of our best-selling lift magnets, it is an awesome product. It has the ability to lift flats and occasional round magnets. It's off the shelf, it's ready to go. We sell thousands and thousands. But what happens is there in certain markets and certain industries, we have to try to modify a standard to get it to work for certain type of applications. Now we have the FX line of lift magnets that are designed for specific applications, and it's off the shelf. So you don't have to wait and pay tons of money for a custom product. One of the things you're going to notice right away is the on-off action of this magnet. On the regular magnet, that handle has to be pulled out, rotated about 120 to 180 degrees. With an FX, you don't have to go 90 degrees. And you see one of the greatest benefits right there is trying to use that inside a channel, where this magnet with the swing going 180 degrees would not work in this type of application. The other aspect of this magnet is really cool is the metal nameplates. First of all, they're metal and they're recessed. So you have protection. So if this magnet is dragged on the side and they get dragged and banged and beat up, it is replaceable, but it's metal, and it's recessed, so it resists scratching. One side's pictorial and the other one's script. So an operator that may not be able to read very well can look at the pictures and be able to see exactly what the magnet will do, whether it's flat, round, or in a vertical position. Paul, you want to talk about some others?
The reason we like the FX series of magnets is, like Pete said, this magnet we often have to modify or make into a custom to work for certain applications. The FX magnets have some unique individual characteristics that tend to let them be more usable with less potential, customization or modification to work with these applications. They come right off the shelf. First one here we have is the FXP. The FXP series is made for thinner materials, so it can still turn on and off on thinner plates. And one of the nice things about this particular instance, it also has a little bit taller poles. And the taller poles allow it to fit down in between things like channels, I-beams, so you can lift from that side without having to modify a standard magnet.
One of the other benefits of the FXP is with the higher poles, it can be used in higher heat applications because that heat takes a lot longer to transfer to the magnet core. So you can use it up to 400 and some degrees F in applications. There is a certain amount of time off the heat as time on, but in an application where a typical rare earth magnet can only go up to 180 degrees. This goes over 400.
This is the flat plate version of the FX magnets. So again, has the advantage of the 90-degree handles. It's a nice small body, very strong. Will work on some flats and some rounds, but in order for the FX series to work on rounds, they actually have one developed for rounds. What happens here, instead of losing capacity to lift on rounds, it has either the full capacity or near the full capacity for lifting on rounds, where the traditional power lift magnets is derated at least 50% for rounds. This one has poles machined that come on it, designed for rounds. A little bit hard to do just hanging here, but there we go. So that drives all the force where it needs to be. Instead of having a very, very thin line of contact with those smaller bevels with the poles designed for round, you have all the field a lot closer to the surface and the thickness of the steel. Another FX unit we have is the FXV. This one also has some different looking pole shoes on it. This magnet can be used with angle iron, either on the inside or the outside. We get a lot of call for this application, and in the past, we've always had to custom machine poles for the angle iron, for the power lift series.
So one of the things nice about this is it works like Paul said. When a customer is dealing with angle iron, they have one row where it's called legs down, going all the way across. The next layer is legs up, and so they're stacked within each other to get the most on the pallet. With these type flat magnets, it was always difficult to do. Now we've got one designed to go either legs up, legs down. Does still work on flat. It does do a box square tubing on the angle. Very versatile. But now, like I said before, we've got a specialty designed product that's on the shelf, ready to ship, ready to go.
I already talked about the FXR magnet. So next we'll talk a little bit about the FXC. I always forget the initial on this one, forgive me. This one is designed and has multiple poles on the bottom. It has 4 poles instead of 2, which allows the field to be transferred into thinner parts fairly easy, and also into round parts that have a hole in the bottom of them. You can still turn it on because you have a little bit less throw depth to that magnetic field. So it allows you to turn it on thin parts, and if there's limited contact surface, like in a tube or a ring. It has a very high center too, so even if you're going down, like for instance with this part upside down, you can still get down in there and actuate the handle. Can't pick it up though because this table is steel, so there's a little bit of transfer down in there. So Pete just gave me the good advice not to look like a weakling and not be able to pick that up on camera.
Go to pick it up and it doesn't move because the steel's in there.
Yeah.
But it's really good. It's a great product for shaft ends of pipe, brake drums, anything material handling where a customer is looking at something with a hole in the middle or a radius where a flat magnet wouldn't work because it doesn't have enough magnet to steel contact.
Yeah, for instance, if we try to use the standard FX magnet or a standard power lift magnet, it gets a lot harder to turn that handle because it's not contacting that round surface as well.
Tony has point.
And it also loses a lot of its holding value because you have very limited contact with the magnetic poles that are there, where this magnet has contact all the way around that diameter.
So on the permanent magnets, what we talked about before is these two are very similar. They're both designed for mostly flat. They both work well. They have different features: the metal nameplate, the fixed lift lug, the 90-degree throw, the metal top on the end. Almost everything on the outside of this is replaceable. So with spare parts, that magnet can look brand new after many years in service. You want to talk about the FXE?
Yep. Another addition is this is a electrically controlled permanent magnet. So it uses some electrical coils inside to basically turn a permanent magnet on and off. This magnet has to plug in to your customer's source of power in order to turn on and turn off. The nice thing about it, if you lose power, it stays in the on position. It's very safe, unlike just a regular standard electromagnet that you either have to have a expensive battery backup for, or you just have to make sure you don't lose power because it could potentially drop the load. There's several features that this magnet has that are really nice. One is that the lift lug actually has a sensor under it. So if you have tension on this lift lug, when I pull up on it, you would not be able to turn it off or on until it's set down on a steady, secure surface. It also has two buttons. You have to hit the proof and the release, or the proof and the grip to turn it on. And it also even has a test function for 33% lifting. So that test function basically allows you to test the load before you lift it. You hit the test button, it turns it on 1/3 of its power. You make a test lift. If it works, you set it back down and you turn it all the way on to 100%, and you know you have a safe lift now. This unit also comes with a nice little flexible antenna, because it has a remote control that can come with it as well. So the operator can run this magnet out to the center of a plate that's out of their reach, set it down, hit a button on a remote control, turn it on, turn it off. They can even do the test lift function. That makes it safer, so operators aren't crawling up on large plates or climbing onto things they don't need to climb onto, or having to reach way out, potentially a back injury, even if they can reach the magnet, and try to throw a handle that's got some force to it. It's just simply a push of a button.
And it's really nice because you look at these types of magnets, and these are what's called close proximity magnets, where the operator has to be in close proximity to operate them. With the FXE, like Paul mentioned, you can do it if you need to or want to. The button's on board. But the benefit of this is now you can do it with a remote control that's wired, remote wireless, but it's synchronized to that magnet, won't affect any other magnets. So it gives the operator a chance to control the load without touching the load. Safety is always our concern, and I'm sure it's your concern for your customers as well.
Yeah. This unit is a standard unit designed for flat plate. If needed, we can do some of the customization stuff that we've done in the past to like our power lift series to make it work with rounds or different shapes or configurations if needed. They can also be used to work in series with multiple magnets off the same remote. You know, that's not necessarily off the shelf. That takes us a little time to get to it, but it is a very nice, very safe magnet. There are lots of different sizes and strengths and configurations that have all the same functionality, depending on what the working load limit your customer may have.
So one of the other big announcements we're very, very proud to announce today, and you may have heard this through the industry news already, but we have acquired Walker Magnetics. So now we've added Walker Magnetics products to our family of products that we can provide you to your customers. Walker gives us a whole lot of different products that we didn't have before. I always kind of like to talk about, synergies between customers. Where do we overlap? When this is industrial magnetics and it's lifting capacity, and this is Walker's. So we overlap with one product, our power lift. Other than that, they make a lot larger lifting capacities and sizes and products like battery lifts and round electro lifts. But they do steel service center, they do 40-foot plate, 3-inch thick, 5-inch thick. It's amazing the applications that they do that we don't. So it's a perfect fit, and we're really proud to have them as part of our company now.
Yeah. Very exciting news. I'm sure you guys have all been into steel service centers or places handling large bundles of steel, large coils of steel. Walker has those solutions, and they've done those solutions for years. So we'll be able to help you guys out those types of applications as well. Even if it's a single large capacity magnet or a beam system, a telescoping beam system, what they can do in the heavy lifting and what now we're able to do that we're partnered with them is very impressive.
We give you a whole new arsenal of products that you can sell to your customer. If it's steel, regardless of the shape, regardless of the size, we now have a magnetic solution for you. Please continue to contact your Walker people if you are working with them already. We're making this transition to us, but right now continue to contact them, and I'm sure things will change down the line.
I think we're kind of open, ready for the questions part of this.
Yeah, thank you guys for your presentation. We did have some great questions come through during your session. And the first one is, does repeated exposure to high heat affect long-term magnetic efficiency?
Yes, I think the question was high heat and what it does to the magnet. Each type of magnet material has a high and a low end of a temperature scale. We don't usually talk about the low end because it's minus 27 F, and very rarely you get in applications like that. But on the high end, typical rare earth magnet material made of neodymium magnet material can go up to 180 degrees. So if you're dealing with hot stamped parts, or parts coming out of a furnace, and you have to pick them up, you have to be careful of those temperature readings, because the longer the magnet sits on there, the weaker that magnet will get. Sometimes it's reversible when it cools down, never the whole amount. So once that magnet's exposed to 180 degrees, it's pretty much not as good as it used to be.
Yeah, if you get over 100, the higher it gets, the more you lose. And every time it gets over that temperature threshold, it will lose a little bit more and bounce back a little bit less. It'll get weaker and weaker over time. So if you have high heat applications, we do have solutions for those. We have the FXP as well as we can make other magnet solutions for high heat applications. We've done lots of that. We just have to be aware of that up front, and we can use different types of rare earth neodymium material that can go to hotter temperatures, or we can even use a material called samarium cobalt. It's not nearly as strong as neodymium, so it takes a bigger magnet to do the same job, but we can make magnets with samarium cobalt, which gets you into the 300-400 degrees Fahrenheit range.
Next question is, are there minimum and maximum allowable material thicknesses for full strength?
Definitely. Each magnet, as you go bigger, they require more thickness in magnetic steel to be able to turn on and fully absorb the magnetic field. So the smaller magnets can handle things like this one can go all the way down to 9 gauge, can go all the way up to 2 to 3 inch thick. So, but you have to be careful you select the right magnet for the application. One of the biggest mistakes a lot of people have is they think, well, I've got a 1/4 inch plate and I got 3 inch plate. So I'm going to buy the biggest magnet I can that'll handle all. It doesn't work that way with magnets, unfortunately. You have to get we do the 80-20 rule. Get a magnet that'll work for 80% of your production. However you're handling that 20% or the big thick plate once a year, continue that way. That way you have a magnet that you can work every day.
And we have data on our different magnets on different ranges of thickness. So if you call us up and you ask us the question about your application and you know the range of steel you're going to be trying to lift with it, or your customer is going to try to lift with it, let us know that. We can recommend the best magnet for your application. Sometimes it may be this FXP. Sometimes it may require custom pole shoes on a power lift because it gets even thinner. But all that is possible. We just need to know the details of the application, and we can work out a solution for you.
Okay, next question. What metals are not recommended for use with lifting magnets?
Well, most 400 series stainless steel is fine. Obviously, anything in the 300 series is not magnetic at all. There's a lot of chrome alloys that are weakly magnetic. So a lot of times if you have an application for a customer that's using some kind of a chrome alloy, we're often going to ask for a sample of that particular product or piece that they're trying to lift, because it may still be able to be lifted safely, but it may take a lot larger magnet to do it. And it may not be a magnet that turns on and off with the handle, because it may be too hard to actuate that handle manually. You may have to either actuate the magnet with electric or an air actuator on a magnet like this, or it may be even a custom magnet altogether that works with air cylinders or hydraulics. We've even gotten into to lift and lower a magnet inside of a housing. But we've done lots of high heat applications. We've even done them with electromagnet lifts. And with Walker, we're going to have higher capacity electromagnet lifts than we used to. So there's potential there. We just have to understand the alloy and maybe possibly test on to make sure that they're getting the safety factor that we require.
We get asked all the time for aluminum. Can you pick up aluminum? And boy, I wish we could. It's not magnetic, so it just doesn't work.
Next question is, are all of the units you've shown considered off the shelf and readily available?
All these are on the shelf, ready to ship. Give us an order before 2:30 and they'll ship that day. We can drop ship directly to your customers without you having to incur any additional handling costs or any fees that are associated with that. So we're just excited that we can solve problems that used to take a custom magnet. Now we can do it off the shelf.
Okay, we have time for one more. What is the repairability of these products?
That's a very good question. All magnets get beat up. I really kind of look at the field when they come back for their annual breakaway test, which we recommend, and so does ASME, that they be tested annually to see if they're working to the level they're supposed to be. They come back here so beat up, it's hard to recognize. With that, though, they can be tested. They can be certificate that says it passed its breakaway test. And like we mentioned, all the outside components of the FX versions are replaceable. So you can get a replaceable label, replaceable end caps, replaceable lift eye, handles, everything's replaceable. So when it goes back out, it looks like it's virtually brand new.
Yep. And we ship every magnet out with these little tags on them. One of them is a retention tag that you punch the service year and month that you started using the magnet. And we recommend and we send in a manual that they send it in once a year for inspections. And that's a big part of our business. We do a lot of magnet inspections and calibrations. So the customer can send their magnet in a year down the line and we'll check it, we'll test it, recertify it, send it back out to them. And if there's anything needed that's going to cost money, we'll give them a quote, and it gives you guys an opportunity to earn some money on repairs as well.
So once you have a customer with a lift magnet, you have annual income from that, whether they buy another one or they just want you to test it. We can test it here, or we have a machine that you can purchase and test at your location. But it's an income stream that works out really well, and it keeps your customers safe, and that's the whole idea.
Yep.
The other thing I wanted to point out is we have an RFID chip on all our lift magnets. So anything we sell on a lift magnet will have an electronic chip on there that contains the serial number for that product.
We store all the test data in a database for that serial number for that RFID chip. And your customer could also, if they have RFID technology, or you guys do, and you keep track of stuff for your customers, you can scan that information, get that serial number, and create your own spreadsheet or data for that chip.
Okay, guys, thank you very much. Peter and Paul.